the last thing I want to talk about associated with chemistry for now is thinking about acids and bases. And the reason this is so important is because of pH. Your body is very sensitive to changes in pH. So what we look at is how acids and bases can affect pH. And when we're looking at these, we're actually focusing on hydrogen ions. So this would be our regular hydrogen minus its electron, right? Gives you H+. We say I had that positive charge. And hydroxide ions. So it probably stands out to you that a hydrogen ion plus a hydroxide ion would give you water, right? Okay, so we've got to think about this. But regardless, we've got to look at the reactivity. These things are going to really impact the environment and really impact your body. And we do it based on proton or hydrogen plus concentration. This is also known as proton. Why is it also called a proton? So regular hydrogen has 1 proton, no neutrons, 1 electron, right? So if you take away its electron, what's it left with? 1 proton. So an H+ is also referred to as a proton. So when we look at acids, we're going to look at the ability or the mechanism in a solution that will cause the H+ concentration. So brackets like that equal concentration. Or some of you may be able to think about as a percentage maybe of a solution. It's not a great way to think about it, but it'll get you started. Okay, increase in the H+ or protons in a solution. Acids cause H+ to increase. Bases then, what do you think they do? They cause H+ to decrease. So in an acidic solution, what we look for is a high concentration of H+. In a neutral solution, they'd be 1 for 1. Okay? In a basic solution, you have fewer H+, but you have more hydroxides, OH-. So when we look at this, we talk about it on a pH scale, right? Well, when we talk about a pH scale, we actually look at a pH scale ranging from 0 to 14. And this is actually something known as a log scale, meaning that we're taking into account the fact that with each change in 1 unit of pH, this actually equals a 10-fold increase or a 10-fold change, increase or decrease in the H+ concentration. Meaning that we may talk about pH of 2 or pH of 3, but that actually on our scale means that between vinegar and cola, so being more acidic means higher H+ concentrations. So if I go from tomato juice at 4 to vinegar or soda at 3, this is actually a 10x increase in the number or concentration of hydrogen ions. Those are huge changes. If you actually went from, let's see, water at 7 to lemon juice at 2. So 7 to 6, 5, 4, 3, 2. You'd have 10, 10, 10, 10, 10. Wow. Those are huge increases in the number of H+ or protons in the solution, right? And what we look at is the fact that things down here at pH of 14 that are what we call basic are just as dangerous as these things at the top that we call acids. And the reason is things that are very, very basic, like oven cleaner, are trying to steal H+. And when they do, it can be very, very dangerous for you. So we can actually get burns from things that are extremely basic and things that are extremely acid. In your body, though, what I'm concerned about is that everything is extremely sensitive to pH change. Enzymes, we said, are proteins. If you change the pH, it falls apart. Try putting a piece of hamburger in a glass of Coca-Cola and walk away for a couple of days. When you come back, it'll be gone. It actually eats it. It's actually denaturing it or making it fall apart. Your cell membranes fall apart. So the things that are going to protect your cells from the outside environment will literally fall apart if your pH is not correct. And eventually it leads to death. So extreme changes in pH are very, very bad for us. So we actually have to moderate this very carefully with things known as buffers. So buffers can actually impact both acidic and basic solutions. So you can buffer either one. So in an acidic solution, we have high amounts of those hydrogen protons, right? High concentrations. So the buffer, if we add a buffer to that, we're actually going to decrease the hydrogen concentration or do what we call neutralize that solution. Basic, the hydrogens are too low. So if we add a buffer to that, we're going to increase the hydrogen concentration and again neutralize that solution. Your body is doing this all day long. Can you finish this?